In the previous chapter of this rlang metaprogramming tutorial, we had a look at terminology, and now in this chapter you will see why it is important to know this terminology in order to modify existing function calls. Let's have a look. Let's start. So let's first maybe create a new expression just as an example. It's once again our simple sum function with parameter NA remove, which is false. And now we would like on the next slide to actually remove the value of this NA remove parameter. First, let's see how we can access it. And it's quite easy. In order to do that, you have to remind yourself that a function, with a quote, a function call, can actually be seen as a list, as an R list. And if you remember R lists, there are two possibilities how to access elements, certain elements of this expression of this quote. And this is just by either specifying their position, which is 1, 2, 3, and this is what I have not done here. But what I have done here is the second alternative, and it's by just using its name. And the name here is NA remove. It's what you see actually on the left side of this expression here, and this is why you can just say call sum when you use the $sign, and when you say the name of the constant in this case which you would like to access, and you say NA remove, and you get false as an outcome, which is this false over here. What you will find if you look at R programs is that you can also just write down false without specifying that it is NA remove, and R finds out that it has to be NA remove, which is specified here because it's just on the second position of this function call after the actual object. And in this case you cannot of course access it like that because the name is not specified, but you can easily fix this by using this handy function over here called standardize. You would execute it on call sum and save its outcome in another object, and the resulting expression has the NA remove name of a parameter in it, and this makes sure that you can also access it using this this syntax over here. So if the call sum or if the expression you would like to work with does not have proper names, it's really easy to fix it. And now let's maybe have a look at the really textbook example of metaprogramming, and it's usually about how to modify basically all parts of your source code with our source code itself. So using code in order to modify other code. And in order to do that, we once again create an expression, which is our sum function, which we execute on an object and which has a constant in this case, or parameter NA remove, which is set to false. And now we are going to modify basically all parts which are highlighted here. So literally everything. And in order to modify the function itself, we have to remind ourselves that these functions are based on our definition. They are symbols, and this is why you use the symbol or the sim function in order to modify it by specifying the new name as a character string. Or what you can also do is you can also use expression to specify the new name. If you do that, please do not write with quotation marks. It's fine too, but I rather prefer the sim syntax because that really makes clear that you are modifying a symbol, and because you specify position number 1 of this expression here, it is clear to R that the function itself needs to be modified. If you go to position number 2, you reach the actual object, and you can replace that one as well by specifying the new name of this object. Of course, you should make sure that it exists. Even if you make use of something which does not exist, it would work and it would replace it, but when you try to evaluate it later, of course, then you will see an error. So this is why we choose an object name of an object which we have defined, um, which we have already defined. And by doing it, we can also replace the object on which we execute our sum function, or now the prod function. And what we can also do is we can replace the constant as well. We make use of the same syntax which you have seen on the previous slide, and we specify the new name, which is now true. It is also possible to write expression of true, as similar as we did it here, but it's actually not necessary, because if you remind yourself of a previous chapter, expression or constants are self-quoting, so you don't need to write it and you can just write true, and it works as well. Let's now have a look at what we get as an outcome, and now you see that the sum has become a product. Int v nums is now int v nums2, and that we have changed the parameter NA removed from false to true. And we can also evaluate it now using eval tidy, for instance, and now this new call is evaluated. What we can also do is we can not only kind of change the values of an existing expression. What we can also do is we can either remove existing elements, so delete them completely, and we can also add new ones. In order to delete something, we just have to specify the new value as null. Null is kind of the hint for R to remove it completely. So if we now have a look at what call sum contains now, you see that there is no NA remove anymore, because NA remove was the third element in the previous expression, and we can add it back in, or we can add everything actually we would like back in by writing call sum and now specify the new name of yeah, a new name of this constant in this case, or the new parameter, which is NA remove, and specify its value in the call. And if you have a look at the outcome, you see that NA remove with a value true is back in again. And last thing I would like to show you is that we can not only modify calls on the higher level, we can also modify calls which are kind of subcalls. So if we have a high level call, which is mean in this case, we can also kind of execute it on an outcome of another call, and we can also modify, yes, this included call as well. And in order to do that, we first have to reference it, and this call is on position number 2, because on position number 1 we have the actual function. On position number 3 we would have this constant over here, and on position number 2 you see this call here. So the outcome of position number 2 is not a symbol, it's not a constant, but it's rather another call. And you modify this call exactly the same way as you did it with on the previous slide, by just reaching out to the element which you would like to modify, which is int v nums in this case, and specify its new value. Just maybe one, just to make it very clear, we say please start from the high level call, which is call mean, go to its second position, which is this expression here, which is another call. And because it's another call, we once again need to go to its second position in this case. First position would be NA omit. So please go to the second position of element number 2, and this is the new value which it should have. And now it's we specify int v nums 2, and if we have a look at the outcome, we see that it's no longer int v nums, but int v nums 2. So this slide shows how you can modify even more complicated calls, and really everything can be modified in an R program.